How's it grade 10s? So what I'm going to do today is I'm going to work through that worksheet that you were given the other day, solving right angled triangles worksheet. Okay. So question 1 is saying, they've given you the diagram like that, and they're saying, what is the length of the side X? Okay. So the first thing that you want to do with these trig problems like this is you always want to find your adjacent, opposite, and hypotenuse. All right. So this side here, or this angle here, is 90 degrees, and this side is opposite the 90, so this is your hypotenuse. Always find your hypotenuse, all right? Then go to your angle, and your angle has two adjacent sides. In other words, sides that are next to it. So if you look at your angle here, you've got this side that's next to it, and this side that's next to it. Now you want to find your adjacent. Now your adjacent can't be this one, because you've already chosen your hypotenuse. So this must be your adjacent side, okay? Then you're going to find your opposite side. Well, it's pretty simple. You've got the two sides. This has to be your opposite. But if you have a look at your angle, the side opposite your angle is this one here. Okay, so we have all our sides labeled. Now we can figure out which trig function to use. Now we want to find this one. We have this one. So which trig function has that adjacent hypotenuse combination? It'll be cos. Okay, remember, silly old hens cackle and hackle. So C-A-H, cackle and hackle. So we know that this is going to be cos 38 will be equal to adjacent, which is 7.8, over our hypotenuse, which is x. Okay, now we set up the equation. I want to get the x on its own, so I'm going to multiply up by x, and we get x times cos 38 degrees equals 7.8. Still the x on its own, so I'm going to now divide by cos 38, and we get x is equal to 7.8 over cos 38. Now I can put that on a calculator, and we can get, make sure that your calculator is in degree mode, 7.8 over cos 38. And the whole thing is saying round off to 1 decimal place. So that would be to 1 decimal, 9.9. All right, there's our first one. Not too bad, huh? Question number 2 is saying, what is the length of side A? That one there. So again, I'm going to find my adjacent, opposite, hypotenuse. Straight away, find your 90. The side opposite your 90 is your hypotenuse. Then I go to the angle that we have, and it'll have two adjacent sides, this one here and this one. The adjacent cannot be this one because it's already the hypotenuse, so it has to be this one here. That's your adjacent. And then this side here will be your opposite. Okay, so we want this one, the A. We know this one. So which trig function has that combination of opposite hypotenuse? It is sine of the angle. So we know that sine 64 will be equal to, now if you listen to your little rhyme, what is it? Silly old hens. So silly old hens, opposite over hypotenuse. So that'll be A over 10.8. I'm going to multiply both sides by 10.8, and we get 10.8 times sine 64 is equal to A. I've got the A on its own, so I can just put that on the calculator. 10.8 times sine 64. Round that off to 1 decimal place, and we get 9.7 is equal to A. And we've solved. Okay. Going on to question 3. Question 3 is saying, what is the length side A over there? So I'm going to again find the adjacent, opposite, hypotenuse. The side opposite the 90 is your hypotenuse. Go to the angle that you know and find the adjacent. It can't be this one because you know that, so it has to be this side here, adjacent. And then you find your opposite side. Okay, so this is your hypotenuse, adjacent, and opposite. Okay, so we want this one. We know this one. Which trig function has that combination of adjacent hypotenuse? It's cos, because it's silly old hens, cackle and hackle. All right, so we've got cos 31 degrees equals cackle and hackle, so it'll be a over 16. To get the a on its own, I need to multiply by 16, so it's 16 times cos 31 degrees equals a. I can just put that on the calculator, and we will get 16 times cos 31, and we get to one decimal place, 13.7. All right, and it's not an angle, okay? So we don't put degrees there. Question 4. What is the size of angle X? Okay, so again, I'm still going to do, the process is the same, grade 10s. Find your adjacent, opposite, hypotenuse. So 90, that must be your hypotenuse. Go to the angle, can't be adjacent, has to be adjacent. Go to the side opposite it, and there you go. Okay, so this is your hypotenuse, adjacent, opposite. Now, we've got these two sides here. Which trig function has that combination of adjacent, opposite? Well, let's go through the little saying. Silly old hens, can't be those two. Cackle and hackle, can't be that. Till old age, OA, there it is. So it is tan. So we know that tan X will be equal to, so it's till old, which is O, so that's 10. Age, A, is 8. Okay, so it's 10 over 8. Now, to get X on its own, because it's an angle, grade 10s, you have to do your shift trig function. So we're going to go shift tan 10 over 8. And we only do this when we're finding the angle. And our angle now to one decimal place will be 51.3. Now I must put the little degree sign there because we're finding an angle. With these other examples, I didn't put a little degree sign there because it's a length that we're finding. Okay. Going on to question 5. Question 5 says, what is the size of angle X? So I'm going to find my adjacent, opposite, and hypotenuse. Opposite, or the side opposite the 90 will be your hypotenuse. Go to your angle, find the adjacent, can't be that one. This has to be your adjacent. Then the side opposite that angle is over here. Okay. Now, from this angle, we want to find what X is. We know what the opposite, we know what the hypotenuse is. So which trig function has that opposite hypotenuse? Well, let's go through the saying. Silly old hens, so OH. Oh, we have it, OH. So we know that sine X will be equal to O over H, 10. Okay. On your calculator, because we're finding an angle, we have to go shift sine. So shift sine 7 over 10. Round that off to one decimal place, we get 44.4. And remember, we found an angle, so we must put degrees. Okay. Question 6 says, the diagram shows the cross-section of a ramp. Now, cross-section, guys, is if you're looking at something and you cut it in straight down, and then you open it up, that will be the cross-section, that inside bit. Okay? So that's what we're looking at. So if this is a three-dimensional ramp, they've cut it, and they've just shown it as a 2D image. Okay, so we have the cross-section of a map. The length of the ramp is 30 meters. So that's that bit over there. And the vertical height that it rises is 9 meters. What is the size of the angle A? Okay, let's find our adjacent, opposite, hypotenuse. The side opposite the 90 is your hypotenuse. Go to the angle, find your adjacent. It can't be this one, so it has to be this one. Then the side opposite your angle is over here. And we are looking for a trig function with these sides that we know, which is opposite hypotenuse. So let's go through our little saying. Silly old hens, OH. So it is sine. So sine A will be equal to 9 over 30 because it's O over H. To find A, we're going to go on our calculators, shift sine, because we're finding an angle, and it is 9 over 30. Rounded off to one decimal place, we get 17.5. And it's degrees, because it's an angle. Okay. Question 7. Question 7 is saying, the diagram shows a ladder leaning against a vertical wall. Okay, so there's our wall, there's our ladder, and this is the floor. Okay, it goes on to say, how high up the wall does the ladder reach? So we want to know if over there, that's where the ladder makes contact with the wall. We want to know how high is that contact point. Okay, so we're going to find our adjacent, opposite, and hypotenuse. The side opposite the 90 is your hypotenuse. Go to the angle you know. Find your adjacent. It can't be that one, so this must be your adjacent. Then the side opposite your angle. Okay, so we have hypotenuse, opposite, adjacent. So we want to find this one. We know this one, so we need to find a trig function as that combination of adjacent hypotenuse. So let's go through our saying. Silly old hens cackle and hackle. So it's cos. All right. So we know that cos 20 will be equal to cackle and hackle. And there we have it. So I want to get h on its own. So I multiply both sides by 3.5. So 3.5 times cos 20 equals h. Just put that on the calculator. So it's 3.5 times cos 20. Round that off to one decimal and we get 3.3. Now, they've given us units here, meters, so I'm just going to put that in there. So the ladder makes contact with the wall 3.3 meters up. Okay. Question 8 over here is saying BH is perpendicular to AC. So that means that this is 90 and that is 90. Find X, the length of BC. All right. Now, grade 10, if I look in this triangle here, this BHC, we don't know anything really in that triangle, okay? We don't know any angles. Well, possibly we know a length, but it's not going to help us because we don't know any angles. So what I'm trying to figure out here, if this thing is a perpendicular bisector, okay, I'm going to assume that it is a perpendicular bisector. And so if this is 19, this AC side, it's a perpendicular bisector, so that will be equal to that, right? So what I'm going to do is I'm going to divide that by 2 because those sides are equal. So if we take 19 divided by 2, and we get 9.5. So this side is 9.5, and this side is 9.5. Okay. Now, what I'm going to do now is, let's see how we're going to do this without making it too complex. All right, because this side is equal to this side, or the lengths, right? That means that that angle and that angle are going to be equal. So I can find out, if I call this one B1 and this one B2, I can find out what B1 is because we have angles in a triangle. You know what that is? That is, we can figure out what that one is. So I know that B1 would be equal to 180 minus 39 minus 90. And my reason for that is angles in a triangle. Okay, so if we put that in the calculator, we get 51 degrees. That means that B2 is equal to 51, and its angles opposite equal sides. Okay, so now we know that this is 51. All right. Now, if I look in this triangle here, this BHC triangle, I'm going to find my opposite, adjacent, hypotenuse. So the side opposite the 90 is your hypotenuse. Go to the angle that you know and find the adjacent. It can't be this one because that's the hypotenuse. So this side here must be your adjacent. And then the side opposite that angle will be your opposite. Okay. And I don't even think we need to do that, grade 10s, because I'm just looking here. We've got this side, we've got this side. We can work out that side using Pythag. And I mean, that would be the easiest way. So Pythag, we would have x squared is equal to 9.5 squared, which is this side, plus this side here, which is 11 squared. Okay, so we get x squared is equal to 9.5 squared plus 11 squared, and we get this 211 comma, I'm going to round that off to 1 decimal, it's 3. Now I need to take the square root of that to get the x on its own, and we get x is equal to 14.5, and they haven't given us any units, so I'm going to leave it as that. All right, just using Pythag. Right, so that was a bit of a random one, not having a trig function, but anyways, it is what it is. Okay, question 9. Question 9 is saying, in the figure below, AB and CD are perpendicular to the side BC. And you can see that AB is 90 to BC there, and CD is 90 to BC there. So they're both perpendicular to that side BC. They go on to say, and the size of the angle ACB. So we go at ACB. So this is your angle ACB, and that is 31 degrees. Okay. So you can always tell how you do it. So they're talking about angle ACB. The middle one is always your angle. Okay. They're going on to say, find the length of segment BD. So we want to find out that length over there. So I'm just going to draw in a little dotted line so we can see that visually. So they're asking for that length there, BD. Okay, so let's have a look, see here. In this triangle here, this BDC one, I know that angle, and then I don't know anything else. So I can't really solve for that. If I look at BAC, I know that. I can work out BC using trig functions. Once I've got BC and I've got that one, I can use Pythag to work out that one. So that's how I'm going to do it. So in triangle ABC. And the reason why I have to do this, grade 10s, is because there's more than one triangle. All right. So if we look at this ABC triangle, opposite the 90 is your hypotenuse. Find the adjacent side to your angle. So it's this one. And then that side is the opposite. Right, now remember what I want to do is I want to find this BC side. I know this side here. So I'm looking for a trig function that has that opposite adjacent combination. So let's go through our little saying. Silly old hens, doesn't work, cackle and heckle doesn't work, till old age. So it is tan. So it's tan 31 is equal to old is O over age is this BC side. Okay, I'm going to multiply both sides by BC. So we get BC times tan 31 is equal to 6. Still want to get the BC on its own. So I divide both sides by tan 31. 6 over tan 31 degrees. Right, put that on the calculator. 6 over tan 31. Round that off to 1 decimal place. So that's going to give us 10. So it's 10, the whole thing, to 1 decimal place. And I just want to check, have they given us units? No, they have not. So I'm just going to leave it like that. So now I know that that's 10. Now, if we look at this triangle, this BCD triangle, that's 90. We know this side, we know this side. We can work out the side using Pythag. So in triangle BCD, we know that BD squared will be equal to BC squared plus CD squared. Okay, I'm just going to fill in my information. So BC is 10 plus CD is 9. Okay, I'm just going to put this on the calculator. And we get 10 squared plus 9 squared. 181. Take the square root and round that off to 1 decimal place. We get BD is equal to 13.5. And that's what they wanted. Okay. Question 10. Right, question 10 is saying ABC is a right triangle with a right angle at A. Find X, this over here, the length of DC. So again, we've got multiple triangles here. So what I'm going to do is I'm going to work with triangle ABD. And with that triangle ABD, I'm going to find AD, the side AD. Then what I'm going to do is I'm going to work with the side ABC. And I'm going to find the length AC. Then what I'm going to do is I'm going to take the length AC minus AD. And you'll be left with AD. You'll be left with this DC, sorry. Okay. So let's go for it, grade 10s. So in triangle ABD. I'm going to use Pythag to find this. So it's going to be AD squared plus AB squared equals BD squared. Okay. So AD squared plus 10 squared equals 14 squared. So we get AD squared is equal to, now I'm going to take 14 squared minus 10 squared. So we take 14 squared minus 10 squared and we get 96. Take the square root, round that off to 1 decimal, and we get 9.8. All right. Now, what I'm going to do is I'm going to do the same for triangle ABC. Okay. So we know that this AC squared plus AB squared will be equal to BC squared. Now here comes the little tricky bit with AC. What is AC? Well, AC is going to be, we just worked that out to be 9.8. So it's going to be 9.8 plus X, or X plus 9.8. Okay, plus AB is 10, equals BC is 16. Okay, before I work out what this is, I'm going to work out here. So we're going to go 16 squared minus 10 squared. So 16 squared minus 10 squared, and we get 156. 156. Take the square root to get rid of that, and we get x plus 9.8 equals, so I must take the square root of this one to one decimal place, 12.5. Just take the 9.8 to the other side, so it becomes a minus, and we get 12.5 minus 9.8. And we get x is equal to 2.7. And that's what they wanted, grade 10s, so not too bad. All right, I hope that made sense, and you guys understand the worksheet a little bit better now. Okay, thank you.